I am going to start second class. For class 11, sixth chapter. And to something, because so first of all, associative law. Number 1, associative law. Number 2, commutative law. Commutative law. Next, distributive law. Distributive law. Associative law, commutative law, distributive law. Identity law. Associative law. Number 1, associative law. Number 1, A union B union C equal to, within bracket, A union B, outside bracket, union C. Number 1. Number 2, A intersection B intersection C equal to A intersection B intersection C. So these two are called associative law. First one is A union within first bracket B union C equal to, within first bracket A union B, outside the bracket union C. The number 2, A intersection B intersection C within bracket, again equal to, within first bracket A intersection B intersection C. So if we want to prove it, then first number, let us see. Associative law, first one, let X belongs to A union within bracket B union C, that is implies and is implied by X belongs to A or X belongs to B union C. X belongs to A union for or, and X belongs to B union C. That one implies and is implied by X union A or X belongs to B or X belongs to C within bracket. Then again, changing the bracket, X belongs to A or X belongs to B within bracket, or again X belongs to C outside the bracket. That is X belongs to A union B or X belongs to C. That is X belongs to A union B within bracket union C. Therefore, A union B, A union B union C will be subset of within first bracket A union B union C. Is the number 1. And A union B union C will be subset of A union B union C. Number 2. Combining 1 and 2 we have, from 1 and 2 we have, from 1 and 2 we have A union B union C equal to within first bracket A union B union C and so on. So if we want to prove this one, then at the very beginning we have to assume X belongs to A union within first bracket B union C equal to X belongs to A or X belongs to B union C. That is, we can expand it X belongs to B or X belongs to C. Then this first bracket can replace here in between first and second. So X belongs to A or X belongs to B. Or outside the bracket X belongs to C. This one, if we want to combine it, then it will be X belongs to A union B or X belongs to C. Again, if we want to remove this or can replace by union. So X belongs to A union B union C. That is, this one subset of this. Again, this one will be subset of this. This 1 and 2. Combining 1, 2, that one we can prove. So in the same way, we can prove in case of intersection also, saying associative law, S, just we can replace union by intersection, and or by N, union by intersection, and this can also be and 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 this will be intersection, 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 this one intersection, 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 union by intersection, union by intersection. This is number 3. Second one, if X belongs to A intersection B intersection C, then X belongs to A intersection for N, X belongs to B intersection C. For intersection again, X belongs to B and X belongs to C. This first bracket can give in between first two, X belongs to A and X belongs to B, and X belongs to C outside the bracket. Then from this first bracket, this first bracket can give in between A intersection B and X belongs to C separately. When X belongs to this intersection, N for intersection C. Finally, this will be subset of this one, again this one will be subset of this one. So if you want to combine them, then this way it will prove it. So this one all about associative law. Now, commutative law. One note, if A is a subset of B and B is a subset of A, then A will be equal to B. If A is a subset of B and B is a subset of A, then A will be equal to B. So this one is a formula or no, you should remember it. It's a very important formula. If A is a subset of B and B is a subset of A, then A must be equal to B. The next commutative law, A union B equal to B union A. Number one. Number two, A intersection B equal to B intersection A. Let, number one, let X belongs to A union B implies and is implied by X belongs to A or X belongs to implies and is implied by X belongs to B or X belongs to A. That implies and is implied by X belongs to B union A. Therefore, A union B is a subset of B union A. Number one. And number two will be B union A will be subset of A union B. This is number two. So from 1 and 2 we have from 1 and 2 we have A union B equal to B union and split. So in case of commutative law, if A union B equal to B union A, then and A intersection B equal to B intersection A, this is one is called commutative law of union and intersection separately. For union, let X belong to A union B. That is X belongs to A implies and is implied by or X belongs to B. B can write first and A can write second position. Then if you want to combine them, then you can write X belongs to B union A. That is A union B will be a subset of B union A. And from the reverse implies we can say B union A will be a subset of A union B. So if we want to combine these 1 and 2, then we can write this one equal to this one. From note. That is, since A is a subset of B and B is a subset of A, implies and is implied by A equal to B. Since A is a subset of B and B is a subset of A, implies and is implied by A equal to B. So by that relation, we can, under that relation, we can write, if we want to combine 1 and 2, then this one we can write. So in case of intersection, just if we stand union by intersection and or by and, then second one proof easily we can show it. That is, say A intersection B or can replace by and or can replace by and. Then union into intersection, we are also saying replacing union by intersection. We are also union by intersection. In this case also saying. So in this way you can show second one also. X belongs to A intersection B implies X belongs to A and X belongs to B. You can replacing this one, X belongs to B and X belongs to A. Same thing. That can combine X belongs to B intersection A. That is this subset of this and this subset of this. So then 1 and 2 combining these two, you can write A intersection B equal to B intersection A. In this way you can show. Since A subset B and B subset A implies A equal to B. So from that relation we can write this. Now, distributive law. Distributive law. Number 1, A union B intersection C equal to A union B intersection A union C. So one more, this can written as ADC also, A intersection now B union C equal to A intersection B union A intersection C. So to the first one, number 1 to let X belongs to A union B intersection. That implies and is implied by X belongs to A or X belongs to B intersections. That implies and is implied by X belongs to A or X belongs to B and X belongs to C. That implies and is implied by X belongs to A or X belongs to B. And X belongs to A or X belongs to C. That implies and is implied by X belongs to A union B and X belongs to A union C. That implies and is implied by X belongs to A union B intersection and means intersection A union C. A union C. Therefore, A union B intersection C subset of A union B intersection A union C. Number 1. And number 2 will be A union B intersection A union C. The subset of A union B intersection C. Number 2. Combining 1 and 2 or from 1 and 2 we have from 1 and 2 we have. Henceforth. From combining 1 and 2 we have A union B union A union B intersection C equal to A union B intersection A union C. Henceforth. So similarly, second one also same way we can prove it. Just replacing union by intersection and intersection by union. Second one also we can prove it in the same way. So from the beginning once again, I want to explain it. For this first proof, X belongs to A union within first bracket B intersection C. That can be written as X belongs to A union for or this is the same X belongs to B intersection C. For intersection it will be and. So X belongs to B and X belongs to C. Now we can write X belongs to A or X belongs to B. This and will come in the middle. Then again X belongs to A or X belongs to C. Or can replace by union or can replace by union. Then N. N can replace by intersection. So finally this will be subset of this one and this will be subset of this. If we want to combine these two, then we can write this one. So similarly, second one also same way we can prove it. So just we have to change union by intersection and intersection by union. Let us see. Second one proof. If these are u by h, using them, it will be and this will be union, this will be and, this will be or, this will be and, this will be and, this will be or, this will be or, this will be intersection, this will be intersection, then intersection, intersection, union. So here also intersection, union, intersection, intersection, union. This will be intersection, intersection, union. It will be intersection, union. Result, intersection, union. Intersection. So results proof of second one. If X belongs to A intersection, within first bracket B union C equal to X belongs to A intersection for N, X belongs to B union. Then you can replace by or X belongs to B or X belongs to C. Then we can write X belongs to A and X belongs to C. Or X belongs to A or X belongs to C. X belongs to A and X belongs to B implies X intersection. X belongs to A intersection B. X belongs to A intersection B. Or X belongs to A intersection C. Or can replace by union. So finally, this will be subset of this one and this will be subset of this one. Combining these two, this can write. So see, this way it can prove second one also. Let us see the next one. Next one will be difference law. Difference law. An identity law is A union A equal to A and A intersection A equal to also A. This one called identity law. A union A equal to A and A intersection A equal to also A. That one very easy. So you can remember A union A equal to A and again A intersection A also A. Now what is called difference law? These are very important. Sometimes this case can come in the exam. So this is very important. So that is A minus B equal to A intersection BC. A minus B equal to A intersection BC. That is called difference law. So let X belongs to A minus B. That implies by X belongs to A and X doesn't belong to B. X belong in A but not in B. X doesn't belong in B. A minus B means X belongs to A but not in B. That is, X belongs to A and X belongs to B. C complement. If X doesn't belong to B, then definitely X will belong to complement of B. Then combining these two, you can write X belongs to A intersection BC. Therefore, A minus B, the subset of A intersection BC, number 1, and A intersection BC is the subset of A minus B, number 2. Combining 1 and 2, or from 1 and 2 have from 1 and 2, we have A minus B equal to B minus. Hence put. So this way we can put difference law. First of all, X belongs to A minus B. Implies and is implied by X belongs to A and X doesn't belong to B. If X doesn't belong to B, that is X belongs to B. Complement of B. So N can replace by N intersection and A, BC, BC. This implies X belongs to this implies X belongs to this. So this will be subset of this. Again, from the reverse implies this will be subset of this. So if we want to combine these two, then we can write this A minus B equal to A intersection B. So this way we can prove difference law. Now De Morgan's law. De Morgan's law. De Morgan's law. So what is De Morgan's law? There are 3 different forms of De Morgan's law. So all the 3 different forms, let us see. Number 1, A union B, whole complement dash. Complement of A intersection complement of B. This one can be written as A union B whole C means complement of A union B. You can also AC intersection BC. Another form, in this way also can write A union B whole bar equal to A bar intersection B bar. So this complementary De Morgan's law, one form of De Morgan's law. This one also De Morgan's law, this one also De Morgan's law, this one also De Morgan's law. Just their fraction is different. So in case of union, this way. And in case of union, second De Morgan's law it will be, in case of intersection, A intersection B whole dash equal to A dash union B dash, or A intersection B whole C equal to AC union BC, or A intersection B whole bar equal to A bar union B bar. So this is another form of De Morgan's law. So this one also De Morgan, this one also De Morgan, this one also De Morgan. So how to prove this De Morgan's law? So first one I'll show. Others you can try yourself. So first proof, from the first we can show the second one also just for dash. So let us start. Proof of De Morgan's law. How to prove it? How to prove this De Morgan's law? let number 1 X belongs to A union B whole complement. This implies is implied by X doesn't belong to A union B. If X belongs to the complement of this one, A union B whole dash, then X doesn't belong in their union. Cannot exist. That implies that this implies by X doesn't belong in A. In case of union, whenever it does not belong, then union can replace by N. X doesn't belong to B. In case of does not belong, union can replace by N. And intersection can replace by O. So since it is union, so we can write N. That implies X belongs to complement of A means A dash, and this one X belongs to B dash. If X does not belong in A, then definitely X will belong in A dash. Similarly, X doesn't belong in B means X will belong in B dash. That is, X belongs to A dash intersection B dash. X belongs to A dash intersection B dash, and can replace by intersection. So, therefore, A union B, A union B whole complement, it will be subset of A dash intersection B dash. Number 1, and number 2, A dash intersection B dash, the subset of A union B whole complement. This is the number 2. So combining 1 and 2, or from 1 and 2 we have, from 1 and 2 we have A union B whole complement equal to A dash intersection B dash, and so. So similarly, we can show the second part of De Morgan's law also, same way. So explanation of the first one, first De Morgan's law, X belongs to A union B whole complement. That implies and is implied by X or doesn't belong in A union B. If it belongs in their complement, then it cannot exist in the set. So after removing the complement sign, if X cannot exist between their union. So if we want to expand it, then X does not belong in A and X doesn't belong in B. If it is does not belong, then union can replace by N. If X does not belong in A, then X will belong in A dash, and X belongs in. Similarly, X does not belong in B implies X will belong in B dash. So X belong in these two. If you want to combine them, then N can replace the intersection. So X will belongs to A dash intersection B dash. So finally, this will be subset of this one, and this one will be subset of this one. From 1 and 2, if we want to combine them, then this one can prove it. So similarly, second one also same way can prove it. Just you have to replace union by intersection and by O. So let us study. Second one, proof. Let X belongs to A intersection B whole complement. Then this can replace by this. If it is belong in complement of these, then it cannot exist in their intersection. And in case of does not belong, intersection can replace by or. Intersection can replace by or. Or means union. Therefore, A intersection whole complement of A intersection B will be subset of A dash union B dash, and A dash union B dash will be subset of A intersection B whole complement. So finally combining 1 and 2 we have whole complement of A intersection B equal to A dash union B dash. This is all proof of second one. So X, if X belongs to A intersection B whole complement, then X does not belong to A intersection B. In case of does not belong, and or intersection can replace by or. Intersection can replace by or. So X does not belong in A means X belong in A dash. X does not belong in B means X belong in B dash. So or can replace by union. So X belongs to A dash union B dash. Therefore, A intersection B whole complement will be subset of A dash intersection B dash, and A dash intersection B dash will be subset of A intersection B whole complement. Therefore, this and this equal. Hence, proof. This is known as proof of De Morgan's law. So, through the Venn diagram also, this complementary law we can show them. De Morgan's law, proof of De Morgan's law is an union, universal set. This is A, and this one is B, A and B. Then union of this whole, that is A union B whole complement will be equal to complement of A union complement of B. This can written as complement of A intersection complement of B. If we want to show them A B, complement of A means B1, complement of A, this is A, this will be complement of A, plus A and B, two sets A and B, complement of B will be this one, so complement of A and intersection complement of B. Complement of A, this will be complement of A, this will be intersection, it will be complement of intersection complement of B, complement of B. Their combined and intersection will be is equal to A B. So this one is nothing but complement of A intersection complement of B. So finally it will be complement of A union B means excluding this one, this area will remain. This will be complement of A union B, and intersection of complement of A and complement of B will be also same area. That is why they are equal. So these are through the Venn diagram we can show.